Hello everyone, welcome back to our channel. Today we are going to discuss about linked list cycle problem. This is one of the most common interview question. So here the question is given the head of a linked list, determine if the linked list has a cycle in it. There is a cycle in a linked list if there is some node in the list that can be reached again by continuously following the next pointer. Internally, POS is used to denote the index of the node that tail's next pointer is connected to. Note that POS is not passed as a parameter. Means we can say a cycle exists if some node's next pointer points back to a previous node in the list. Let's say here this list 3 to 0 minus 4. If the list starts from index 0 onwards, our last node connected to first index node. So here they have provided POS also. POS means position. So here the last node connected to position 1 node. But they mentioned that note that POS is not passed as a parameter. Just for understanding, in this example, they have provided POS, but in the function parameter, if you see here, there is no POS. And return true if there is a cycle in the linked list, otherwise return false. So this is the basic question. Let's go through the examples. So in the example one, as we already discussed, our -4 connected to 2 means last node connected to first node. So there is a cycle. And in the example 2, here also our last node connected to first node. Here only 2 nodes are there. So here also cycle is there. Hence the output is true. And in the example 3, there is only 1 node. So there is no chance of cycle. So output is false. So these are the examples. Let's understand this question in elaborative way. So here I am writing again list. D is having again B. B means here. Why? Because here in the question they have provided position as 1. So this is the simple linked list. So let's discuss about the possible approaches to solve this question. One approach is store every visited node in the hash set. While traversing, if we see the same node again in the set means there is a cycle. Let's try to draw. So here first A, after that B, and again C while traversing. After that we got D, and again B means already it exists in the set. So with the count function we can know already that node is there or not. It will return 1 if exists. So with that we can say this list has a cycle. If not, we can say there is no cycle. But with hash set we have one drawback. That is, with hash set the time complexity is O of n and space complexity also O of n. That's why this is not efficient approach. So hash set is not that much of efficient. So now we are going to discuss about efficient approach, which is Floyd cycle detection. Floyd cycle detection approach. Here we are going to take 2 pointers. One is slow pointer and another one is fast pointer. So slow pointer at a time it moves only 1 step, but for fast pointer moves 2 steps at a time. So if there is a cycle, this slow and fast pointers eventually meet. So slow and fast, if both are eventually meet, means there is a cycle in the list. But if fast equal to null means then there is no cycle in the list. This is the simple approach. Let's dry run this one. So here first our slow pointer starts from A and fast starts from B. So now in the next traverse A 1 step at a time. So here slow pointer moves to B and fast moves 2 steps at a time. So from B to C and C to D. So here D, and then from B to slow is C. D is two steps at a time. So D contains B and B contains C. So here both pointers are met. So here we can say cycle. Let's try to understand with a small example which has no cycle. Let's apply the Floyd cycle detection for that one as well. So I'm just rewriting. In Floyd cycle detection, if slow and fast met means there is a cycle. If fast equals to null means no cycle. This is the main logic. And slow moves one step, fast moves two steps. So here I'm just taking one small example, same example. So here instead of connecting to another node, the last node is having null. So here let's start slow from A and fast from B. After that, A one step at a time. So it has B's address. So it is B. But fast is at B. So two steps at a time, right? So first step C and C is having D. And in the next step, B is having C, slow at C, and D, it is having null. So with null, we can't go further. So if fast became null, right? So means it is no cycle. So this is the basic key idea. Let's try to code for this problem. So first we need to check our head is null or our head is having one node. In these both cases, we need to return false because there is no chance of cycle here. After that, we need to take two pointers. One is slow, which starts from head, and another one is fast, which starts from head next. So here we need to check our fast not equal to null and fast next also not equal to null because our fast is moving two steps at a time. That's why we need to take care of this one. And here our main logic. If slow equal to fast, then we need to return true, means it's a cycle. And we need to move slow pointer one step and fast two steps. And in the final, we need to return false. There is no cycle, we need to return false. Let's quickly run this code. Yeah, our solution got accepted. Let's try to submit this one. Yeah, all test cases got passed. I hope you understood this problem clearly. If you have any doubt, please do let me know in the comment section. Please do like and subscribe to our channel. And thanks for watching.